Wireless networking is now commonplace in most network environments. In fact, a lot of networks use it as the primary connection method. Chances are you probably have a wireless network in your home. In fact, setting up a residential wireless network at home is pretty simple. Even setting up the SSID broadcast and encryption protocol on the access point is very straightforward. In an enterprise environment, setting up a wireless network isn't as simple. Let's highlight a couple of things with consumer-grade home routers. You probably only have a single wireless access point at home. This device is actually 3 devices in one: a router, a switch, and a wireless access point. The router connects your home local area network to the ISP's network. The switch allows you to connect several network devices together using an Ethernet cable, most likely unshielded twisted pair. The wireless access point allows for wireless connections to the local area network. An enterprise wireless network is different from a home wireless network in at least 3 different ways. First, instead of having a single all-in-one device, equipment is typically separated into distinct components that perform a single function. For example, a router only performs routing operations, a switch only performs switching operations, and a wireless access point only acts as a bridge between the wireless and wired network. Second, enterprises need to support many more devices and cover a much larger area than home networks. Some enterprises need to support thousands of clients and cover entire business complexes. For example, many universities have wireless connectivity on the entire campus. And third, devices need to be able to move around the enterprise without connection troubles. The transition between different access points needs to be seamless. In an enterprise network, this is done by using multiple access points, which are scattered throughout the campus to provide adequate coverage. The access points will typically all connect to the same local area network through a switch. Now, each of these access points can only support a limited number of clients, so having multiple access points also allows each access point to share the client load. For example, if this switch has the maximum number of connections, new wireless devices that require network access will be connected to this access point here instead. This is possible because the range of the access points here overlap, which actually brings up another important point. Overlapping signals can cause interference. It's also possible for devices to constantly bounce between connecting to this AP, and so on. This could be really frustrating. In addition, if any of these configuration settings on either of these APs is different, then this can cause connection issues, and the more APs you add to the network, the more devices you need to manage. As you can see, a wireless network can quickly become a management nightmare. Luckily, enterprise networks use a device called a Wireless LAN Controller, or WLC, that manages all the access points in a network. The typical enterprise wireless controller will be in a network closet and connected to a switch. The controller can then communicate with and manage each of these APs. In addition to managing configuration settings, the controller can also manage client connections and manage AP loads. In essence, a wireless controller allows multiple APs to work together as a single system instead of each working in isolation. It's important to know that a wireless controller by itself doesn't actually produce any type of wireless signal. That's the job of the AP. The controller only manages the APs. Another type of wireless device is known as a lightweight access point, or LWAP. LWAPs are used in conjunction with a wireless controller. LWAPs contain very little embedded intelligence or technology. They are connected to the wired network via network cable and are able to communicate directly with the WLC, which handles things like client connections, authentication, propagating configurations, etc. Let's next look at the 2 ways a wireless network can be configured. The first one is ad hoc mode. In ad hoc mode, also called peer-to-peer mode or wireless mesh mode, there is no WAP or WLC. Instead, 2 or more wireless devices connect directly with each other to send and receive information. The more devices that connect, the more individual connections are made. And you can see where the term wireless mesh comes from when you see all of these individual connections. The second mode is called infrastructure mode. In infrastructure mode, a workstation communicates with a notebook by sending the signal to the wireless AP, which transfers it to the notebook system. The infrastructure mode is more scalable than ad hoc mode. The infrastructure mode also makes it easy to connect the wireless network to a wired network. It's not easy to do that with an ad hoc implementation. Once you establish the wireless connection between the network interface card and the wireless AP, the wireless network operates similar to the traditional wired Ethernet networks. Now, it's important to know that wireless networks use what's called an unbounded medium to communicate. That is, they send signals in all directions that can be picked up by any device in range. They aren't bounded by insulated wires like wired networks. Because of this, wireless networks are inherently less secure than a bounded wired network, so you need to take extra precautions when securing a wireless network.